We are ready to understand the first law of motion, often called the law of inertia. The formal translation is everybody persists in a state of being at rest or of moving uniformly straight forward except insofar as is compelled to change its state by force impressed. We can understand it in simpler terms. What actually is Newton's first law is an object in motion stays in motion, and an object at rest stays at rest unless acted upon by a non-zero net force. So to summarize, Newton's first law really says no force, no acceleration. No acceleration, no force. Think about a book lying on a table. If we have the book alone, it remains at rest. Now imagine pushing the book with a horizontal force great enough to overcome the force of friction between the book and the table, setting the book in motion. Because the magnitude of the applied force exceeds the magnitude of the friction, the book accelerates, as illustrated in this figure. When the applied force is withdrawn, friction slows the book to a stop. Now imagine pushing the book across a smooth, waxed floor. The book again comes to rest once the force is no longer applied, but not as quickly as before. Finally, if the book is moving on a horizontal frictionless surface, as shown in this figure, so there's no friction between the book and the surface at all, the book will continue to move in a straight line with constant velocity until it hits a wall or some other obstruction. This is the big difference between Aristotle and Newton. Aristotle thought motion needs a force. Newton proved that a change in motion, aka an acceleration, needs a force. So force is not the reason of motion. Force is the reason of change of motion. If there is no friction, a book pushed in space will move forever. Inertia is just the nature tendency of an object to resist a change in its state of motion. The measure of an object's inertia is its mass. An A380 has a lot of more inertia than a Cessna 172, which is why it needs a lot of force to get it moving, and a lot more force to stop it. Let's think about this question. A sailing boat is moving east with a constant velocity. What is the direction of the net force? Circle your answer, and let's check whether it's correct. If the velocity is constant, what's the acceleration? It's zero. And if the acceleration is zero, what does Newton's first law tell us? Newton's first law tells us that net force must be zero if acceleration is zero. So the answer is C, 0. Let's run through a few more quick examples to make sure we have got this. A Pinto is parked. Is there a net force on it? The net force must be zero because Pinto is parked, right? So the net force has to be zero. In order for the net force to be zero, the force from the parking surface and the weight has to cancel. So the parking lot provide a force that is pointing up, cancel the gravity which is pointing down. So the correct answer is A. Now this time, a Pinto is parked in a parking lot. Let's look at another example. A Pinto drives down a highway. on the moon at a constant velocity, where there is no air resistance, what's the Pinto's acceleration? It has to be equal to 0, right? Constant velocity, 0 acceleration. Now this time, the force acting on the Pinto from the contacting with the highway is vertical. The answer is true. Okay, I hope you get this. And before I end this lecture video, I want to give you a very interesting example. An elevator is being lifted at constant speed by a steel cable attached to an electric motor. There is no air resistance, nor is there any friction between the elevator and the walls of the elevator shaft. How does the force exerted on the elevator by the cable compare to the downward force of gravity? Write down your answer on a piece of paper, and I will reveal the answer in the next lecture video.